All right, this one here looks like a lot, but you'll quickly notice that this entire parentheses is raised to the 0th power, and anything raised to the 0 power is 1. So we can imagine this entire parentheses as times 1, and we can effectively ignore it, because anything times 1 is itself. So this whole fraction times this thing over here is just going to be this, this fraction, or this expression. So let's just simplify that. We'll do power of a power, because that's what we've been doing. Might as well keep up with it. So I'm going to multiply this -1 times all of the exponents on the inside. Remember that 2 has an exponent of 1 because it's not written. So multiplying all of those exponents by -1 is going to give us 2 to the -1, x to the +3, y to the -5, all over x to the 11, y to the -9. All right. So what we'll do now is let's move this 2 to the -1 down here. That's, again, a quick way to, well, let's do that for all of our terms with negative exponents. Remember, if you have a negative exponent in a fraction, to make that exponent positive, just move it. If it's in the numerator, move it to the denominator. Exponent becomes positive. If it's in the denominator, move it up to the numerator, and that exponent becomes positive. So I'll take this one, move that down as well, and I'll take the y to the -9, move it up to make it a +9. So this is going to become x to the 3rd, y to the 9th, all over 2, 2 to the 1st, we could say, x to the 11th, and y to the 5th. And what that is going to give us, I see two quotient rules, so x to the 3rd over x to the 11th. 3 minus 11 is -8, so I'll have x to the -8. Y to the 9th over y to the 5th is going to be y to the 4th, all over 2 to the 1st, or just 2. And again, I see another negative exponent appear, so I'll just take it back down and move it to the denominator. So final answer will be y to the 4th over 2x to the 8th. Another quick shortcut: if you see a fraction or an exponential expression that is in fraction form like this, and it's raised to the -1st power, raising something to the -1st power just means, hey, flip your numerator and denominator, or express it as the reciprocal if you want the technical explanation. But the easy way to remember it is, if it's raised to the -1st power, just flip the fraction. So if I did it that way, and starting from here, I'm going to flip that fraction. So I'll have x to the -11th, y to the 9th, all over 2 to the 1st, x to the -3rd, y to the 5th. And then now I can do my simplifying here. So -11, right, minus -3 is going to give me x to the -8. 9 minus 5 is going to give me y to the 4th, all over 2 to the 1st. Again, that's looking exactly like that one. So we'll take that -8, move it down, or x to the -8th, move it down, and we'll have y to the 4th over 2 to the 1st times x to the 8th, and get the exact same thing. All right, last one here. Again, lots of different ways to do these, and the more that you practice on your own, you'll kind of figure out what patterns you notice first and what your preferred method is. There's no right way to do it, just one right answer. So I'll keep doing it the way that I've been doing it, which is looking here. I see that I can do a power of a power property. So I'll raise that -18 to the 1st, and I'll multiply all of these exponents by the -1. So I will have -18 to the -1st power, x to the 3rd, and y to the -4th, all over 3x y times x to the -6th y over, And I might as well just do that again over here. So I'm going to multiply all of these exponents by this 2. So I will have negative 3 squared, y to the 10th, and x to the negative 2nd power. And since I have a fraction times a fraction, I'll just multiply my numerators, multiply my denominators. So I'll have negative 18 to the negative 1 times x to the 3rd times y to the negative 4th times x to the negative 6th times y. And same thing down here. 3 times x times y times negative 3 squared times y to the 10th times x to the negative 2nd. So I'll take it numerator first and then the denominator and just do product of powers. So I see here x to the 3rd and x to the negative 6th. So that's going to give me x to the negative 3rd up top. I also see this y to the negative 4th and y to the 1st. So that's going to give me y to the negative 3rd. And then I have the negative 18 to the negative 1st power there still. Down here I have x and x to the negative 2nd. So that's going to give me x to the negative 1st. I have y and y to the 10th, which is going to give me y to the 11th. And then we have our negative 3 squared and then times 3. So what I'll do is I will move around anything that has a negative exponent from the top to the bottom or the bottom to the top. So I'll take this guy, move him down. This one comes up. And this one go down. Actually, the entire numerator goes down to the denominator. So up, let's see, here was next to the negative 1. So that's going to be our only thing in the numerator now, x to the 1st over, I'll have negative 18 to the 1st times x to the 3rd, y to the 3rd, y to the 11th, negative 3 squared, and 3. So kind of a beast of a problem, but just goes to show you that there are multiple steps involved. You want to take your time with everything. So I can combine those as well and get y to the 14th. So I will have x over negative 18, x to the 3rd, y to the 14th. I might as well just simplify that. Negative 3 squared is 9, and then times 3 is 27. I can do a quotient rule quick right there. And I'll get x to the negative 2nd. So x to the negative 2nd over negative 18 y to the 14th times 27. Now this x to the negative 2nd is going to come down. So we're going to have nothing in our numerator, but when that happens, it's understood that there's a 1 now in the numerator. So I have 1 over negative 18 y, actually I'll put x next, x squared y to the 14th times 27. I can multiply negative 18 by 27. I don't know what that is off the top of my head, so negative 18 times 27 is going to be negative 486 x squared y to the 14th. And there you have it.